And in the orbiter, in the front part of the orbiter, there are a lot of windows. And many of the windows, not the front windows, but the overhead windows and the aft windows, were optically pure. So what you saw was exactly what was on the other side. No distortions, no coloration changes or anything like that. And so in the times that we had free time, the crew would go to the windows and take pictures. And now I'm going to be able to separate the ages of the people out here. We use film in our cameras, for those who can remember film. And so we would take pictures, and the first picture, one of the first pictures I took was this one, the next one, that one, right here. And I don't know, when I was growing up, they used to say the earth looks like a blue marble. Well, for those who know what marbles are, that's what it looks like. It looks like a blue marble. And I took a picture, this is a picture I took. And there was a lot more to this picture than what you see right here. But it is a limitation of cameras. And it doesn't matter whether it's film or digital. The camera tends to focus on the very brightest thing. The very brightest thing here is the Earth. And so if you focus on the Earth and get the resolution, the right coloration, the brightness and everything, what you don't see is over in this picture, part of this picture. And so space is not black like that. The camera just doesn't have the ability to take a bright object and something that is very, very dim. In the middle is the orbiter. Next. So when you look down from orbit, we're only about 250 miles above the surface of the Earth. When you look down, you're looking at things that are occurring at this moment. And I'm looking down, and this is the southern end of India, for those who haven't recognized it. But when you look down, you can see things that you've read about, but it makes sense to you when you see it, actually. See, I can tell you immediately where the predominant wind comes from. I can tell you exactly where the mountains are. I can tell you where the most perfect place to go fishing is. So the predominant wind comes from this direction. And when it picks up moisture from the ocean and rises over the dirt, it rains until it gets to the mountains. And on the windward side, it's green and lush. On the leeward side, it's dry, arid. You see the lighter colored water over there on the right side of the picture? That generally indicates colder water that's upwelled from the bottom of the sea. When it rises, it brings nutrients. Fish love it. You want to go fishing, that's the place to go. Now, if there were a storm moving over this, you'd actually see the storm. You would see it moving. You'd see the lightning flashes inside. When we see lightning on Earth, it looks chaotic. But when you see it from space, when the lightning goes off, it goes whoosh, like that, right up the storm. And so there's no chaos at all. It looks very, very organized. It's an amazing, to be able to see this stuff and then read the book, then it makes sense. Sometimes you're reading the books and it just doesn't make sense until you see it. Next one. Well, we are the third rock from the sun, and that's what they call us, the rocky planets, the first four. But all of the planets we have visited, not by human presence, but by probes or things of that nature. Now, those who remember film will also recognize the error in this picture. And that is, there is another planet, Pluto. And we're going to get Pluto back on this map one day. Now, humans have been only on the moon, our moon. And so far, only the United States has done that. Mars is a great destination. Mars would be a great destination because it's a lot cooler than Venus, which is very, very hot. So that's what our tendency is, to go out further as opposed to in. Next one. So Bob McCall was a good friend of mine. Unfortunately, he died many years ago. But he was a great artist. And what he depicted in this painting was everything that you would sense if you went to the moon. You would see the lander behind. You'd see the astronauts in their suits so that they could survive. You could see Earth. You could see the universe. It's an amazing picture. You see this one astronaut there is holding a flag, not to indicate that the United States has claimed, only that they have been present. And we would hope soon that other nations are able to go to the moon and plant their flags to say, we have been here too. It's an amazing picture. Next one. We've been, in a sense, to Mars. But many other countries have also been to Mars. We are unique. The United States is unique because we've taken a little helicopter up there. And that little helicopter has flown 48 times. And it doesn't collect. What it does is look. It reconnoiters to determine the place where that rover should go and search. Now, why would we go to Mars? Well, the question is always, are we alone? Is there any life out there beyond Earth? Well, we don't know. But Mars has indications that it has water, or had water, or is water there. Water would be a great indicator of of life, of a biological life. And so we're interested in Mars to try to determine if there's any biological evidence that life existed there. But we also want to see if water is there. We see visually gullies that look like they had been formed by water, but we don't know at all. So it's the curiosity about Mars that is intriguing, and we don't have an answer for it. And so what we're doing right now, we're actually, like a little bulldozer. We're piling up the piles of rocks. And soon, 8 or 10 years, next one, 8 or 10 years from now, we're actually going to try to get a probe to go there, pick up some of those rocks, bring them back to Earth so that we can study them to determine whether there is a hint of biological life or water there. But that's in the future. It's a very interesting place to go, and we're going to learn, I hope, quite a lot from it. And then soon, I would hope we have a visit there. So, next one. I wanted to show you this. The pointy thing in the back is the orbiter Discovery, and this is one of my crews. But what I really wanted to show you was our suits. And I don't know if you've updated your house painting anymore. And so all I can tell you is that this is agreeable orange. This is probably one of the most amazing colors. It goes with anything. What do you think? Anything you can wear, it goes with it. I mean, it's perfect. It just matches our eyes, and it just complements anything else that you might wear. When you put the helmet on and the gloves on, it only weighs about 75 pounds. It's a small price to pay. Now, why do we have agreeable orange? Well, after the Challenger accident, it was determined that there was a possibility that a crew, if the orbiter had a failure, could bail out of the orbiter. And so, if you bailed out, we would bail out into the Atlantic Ocean, because that's the way the orbiter goes. The Coast Guard told us that the best color that they could recognize from above, if they had to come search us, was agreeable orange. So that's why we have orange. Now inside, next picture, is what it looks like in the front part of the orbiter. Commander sits on the far side. Pilot sits on this side right here. We're the stupid ones on board. The brilliant ones are the mission specialists, those back there. Scientists, engineers, medical doctors. But not only are they fantastic in their skills, but they are also garage mechanics. So if something breaks on the orbiter, those are the ones who go fix it. Those are the ones who walk in space. All we do is make sure the orbiter performs properly, and then if it's not, to tell the mission specialist what to do. But what I want to show you is all the switches, circuit breakers, gauges. There are more than 2,000 of those things, and each one is critical to the safe and successful mission. And so most of our training is trying to correct failures that our training team has inserted so that we can continue the mission. 2,000. SpaceX has 30. We have 2,000, they have 30. And touchscreen. The next generation, I'm certain, will have only one that says on, and that's it. So you can see the technology improvements, advancements that have occurred between the space shuttle and SpaceX and the current and future space, human space vehicles. Next one. So the space shuttle, you all remember, last flew in 2011. On the back of the orbiter, there were 3 rocket engines called the main engines. And they are fed by 2 tanks in the big brown tank. One of the tanks has hydrogen, the other one has that's liquid hydrogen, liquid oxygen. On either side of the tanks are these 2 solid rocket boosters. 5 seconds before liftoff, those main engines ignite. Their count continues, 4, 3, 2, 1. At 0, the solid rockets ignite, and there is no doubt you're going someplace really fast. Straight up for 10 seconds, then we roll over on our backs like this and flew over you, the Atlantic Ocean. 18 minutes after we took off from Florida, we crossed the west coast of Africa. 18 minutes. 2 minutes after we took off, those solid rocket boosters on either side had burnt all of their propellant, and they were literally blown away from the tank. Parachutes deployed, they landed in the ocean, they were recovered by NASA, refurbished, refueled, and sent back to NASA for reuse. Those main engines on the back of the orbiter continue to accelerate us to something called orbital velocity. And that's the speed that we have to achieve to enter and remain in an orbit around the Earth. That is, orbital velocity is 17,500 miles an hour. We get to space in 8 minutes. From liftoff to in space is 8 minutes. Once we get to that velocity, the main engines shut off. And it feels, just before they shut off, it feels like you have 3 people sitting on your chest. We're experiencing 3 Gs, 3 times the weight of gravity. When the engines shut off, we go from 3 Gs to 0 Gs instantly, and we go, every astronaut that I have ever seen or heard or talked about, they all go like that. And there must be a medical reason for it. I have no idea. But this young man one day is going to tell me why we go woo like that. But now we're in orbit around the Earth, circling it every 90 minutes. And as we go around, the Earth continues to rotate to the east, as it always does. And so every time we come around, we're going to see something further to the west. And so even on a very short mission, you will see almost all of this blue marble. And it is mind-boggling when you look down. Next one. Well, who else goes to space? Well, there's this guy, Branson. Now, if it starts with Virgin, that is Branson. So, Virgin aircraft. I call it Virgin planes. I don't know if any of you have flown that, but that's Branson. He now has ships. I call it Virgin boats. He has Virgin rockets. If he comes to you and says, you could fly on this airplane, turn around, and run as fast as you can away from you, it's probably the most unsafe thing in the world. But he is doing it. So stay away from Branson. Next one. Well, when you came into the parking lot, across the street, you saw those blue and white buildings. That's by a guy named Jeff Bezos. Got something to do with Amazon. He's a multi-billionaire. He has his company is called Blue Origin. And he does a lot of launching. And he's launching in this vehicle. It's called the New Shepard, named after Alan Shepard, who was America's first astronaut who went to space. But he went there, turned around, and came back immediately. You can buy a seat on this. I mean, fly with it. I mean, if you've got the bucks, fly with it. Then you can experience this up and down. You'll have about 8 minutes on orbit before you come back down. Now, he has greater ambitions, and I'll mention a couple of those a little bit later. Next one. SpaceX. SpaceX launches more in 3 days than the government can launch in 7 months. You know, something immediate to him is 2 hours later. To the government, it's 6 months or more. I mean, it's just amazing. And notice his agreeable white suits that don't look anything like our agreeable orange suits. They're about half the weight. They don't have any of the mechanisms that we are used to. But he just reinvents everything because nobody can tell him no. He doesn't have to get congressional approval or any of those things in order to do something. He is going to conduct the first civilian spacewalk between now and June. And he's also talking about boosting the Hubble telescope into a more stable orbit. The second guy from the right is a guy named Jared Isaacman. He's a billionaire, a couple of billion. This was his mission. He brought the people along with him. But he and Elon Musk have kind of joined forces now. And so if you want to watch Elon, watch for this guy, Jared Isaacman. Next one. Here are the two of them standing together. And he's got great ideas about what to do as far as humans are concerned. These two folks are not talking about the moon. They're talking about Mars. So we're talking about a whole new framework of thinking. Next one. There's a company in Colorado near Boulder. It's Sierra Nevada. And they are working on Earth to space station back to Earth, carrying cargo and humans back and forth. This is called the Dream Chaser, and it's being developed within Sierra Nevada in a group called Sierra Space. Now, this is it's an interesting company because this is a lifting body vehicle, very much like the space shuttle. But their thinking is even further ahead than just this vehicle. Next one. They are creating, this is an inflatable, and I wish there were a human here to give you a sense of the size of this thing. But this is about, and a fully inflated one gives you about 3/4 of the same internal volume that our International Space Station has. So instead of carrying these very large aluminum cylinders up there, they're carrying a small package. Once they get on orbit, they inflate it, and there's your volume right there. Great thinking. Now Sierra Nevada is also working with Blue Origin, next one, to create their own space station. And this would be the first civilian space station. Well, there are only two up there now. One's China, and one's the United States. So this would be the first civilian and the third international space station of sorts in orbit. But this is what these folks are thinking about. And I love it because they're, you remember the old days, we're thinking out of the box. Well, they are certainly thinking out of the box in these concepts. Next one. Well, there's another company out there. It's called ULA, the United Launch Alliance. And the rocket that's being used here is an Atlas V, which is so old and antiquated. They've got something called the Starliner on it. It looks like it's built by Boeing. They've been developing it for years and years. It's way behind schedule. It was supposed to launch in April. It started out to carry 4 people. It's now scheduled for 2 people, and now it's delayed at least to the end of the year, and who knows what. When I was last year in February, I said, this program cannot survive. In fact, right after that, ULA was just put up for sale. And so if you're interested in buying a space program that is so legacy that it's obsolete, this is the place. You get a good deal, I'm sure. They'll sell it to you. I don't know when this thing's going to launch, but this again is another government program that is just handicapped by the process that it's in. Next one. Now, Artemis launched in November after long delays. The interesting thing about this, notice the white things on either side. They're solid rocket boosters. It came directly from the space shuttle. On the bottom of that brown tank are 4 rocket engines. Those are exactly the same rocket engines that used to be on the space shuttle. Up in the top, the first white section that you see coming up from the bottom will be a stage that's powered by what we call on the shuttle the orbital maneuvering system, the OMS engines. So they've got all of this recycled stuff, and you would think, man, we're going to be fast. Exactly the opposite. It's the slowest program I have ever seen in my entire life. This was Artemis 1 that launched in November. There's an Artemis 2, an Artemis 3, an Artemis 4, and so forth. I don't know when Artemis 2 is going to launch. But Artemis 1 had a very, oh, by the way, nothing is recyclable. So even though we recycle most of the stuff on the space shuttle, none of this is recycled, except for the capsule at the top. And hopefully with the humans on board, they'll bring them back. But next one, this is the mission it flew. It launched from number 1 up there, Florida, now where you are right now. It went around the Earth and then headed for the moon. And so it headed out at 6. At 7, between 7 and 8, it put out a couple of small satellites of sorts, continued to the moon, to number 9 over there, but instead of entering a moon orbit, as we had done in the past, it actually used the moon as a slingshot to send it further out to number 11, which is about 3,000 miles beyond the moon. It then came back, circled once, circled, and then came back to Earth and landed at number 17. Now, Artemis 2, whenever it happens, will have a crew on board, and they will fly essentially the same mission. This is amazing. Next one. This is the way it looked about 3,000 miles from the moon. You've never seen a picture like this before. This is the Orion capsule on the front. That's where the humans will be on the next one. There's the moon and then Earth there. Now, this was supposed, and if you, after launching this, you would say, okay, in a couple of months we're going to launch number 2. But this one is going to take 2 years or more to launch, Artemis 2. And so if you're excited about one, by 2 years, who cares? So that's one of the problems that we run into with these government programs like this. They are so burdened with legacy that the importance of it and the urgency of it somehow gets blown away. Next one. So this is something you have not seen. This is Elon Musk's space launch. I mean, this is his star launch, or whatever we call it. It's down in Florida. I mean, it's down in Texas right now. It's going to launch. Now, you get a sense, that thing on the bottom, the silver part, he calls it the BFR. And he calls it the Big Falcon Rocket. Others have said other things. This is a big rocket. It's a 2-stager. Next one.
Starship. It's Starship.
Starship. Okay. Thanks. Okay. You can see it on the side over there. Starship. And referencing other vehicles that we know. The Block 2 cargo is the Artemis program on the Space Launch System. The one next to it is the Saturn V that we used to go to the moon 50 some odd years ago. M1 is the biggest Russian rocket ever. SLS Block 1 is the Artemis program. Long March is the Chinese. Yenisei is Russian. The Falcon Heavy is the SpaceX, but bigger. this energia here, I had it here, but unfortunately I don't have a space shuttle on here. The space shuttle would be a little bit shorter than this. And so these are the current or were current human launch vehicles. You can see where Starship is. It is just an amazing vehicle, and I suspect, since they're talking about Mars, that's what this thing will evolve into, is a vehicle that'll take us to Mars. And it's going to do it really quickly, I think. Next one. We all know about the Hubble. Hubble has sent us amazing pictures of the universe for the last 3 decades. And Hubble looks kind of like a telescope. We've accepted it as looking like a telescope, and it is in Earth orbit, meaning it circles the Earth just like the Space Shuttle, the International Space Station, and everything else has been in orbit. Next one. And this is a picture taken by the Hubble. But I show you this not only to show you the quality of the picture from a Hubble, but this is what it looks like in the window if you don't have that pesky Earth. This is what the heavens look like when you're outside the atmosphere and looking up. And it almost looks like it's one-dimensional, two-dimensional, until you realize that at the speed of light, and if this were a strobe, this one right here were a strobe, instead of a solid light, and it's strobe, it would take 10 million years for the light to get to your eye. 12 million years, the light to get to your eye. 8 million years, the light to get to your eye. So you're not looking at something that's flat. You're looking at something that has infinite depth. And so when you look out there, you're not looking at something that is occurring right now. You're looking at history out there. So it's just a fascinating experience to look out and understand what you're seeing out there. And the universe is expanding. And we don't understand, and so I'm hoping that one day one of these youngsters will come up with a theory that explains what is happening with our universe. Next one. Now this is a picture also taken by the Hubble. This is the nebula, which is essentially gas and debris. To me it looks like an oil painting, or until I saw the next picture, or a picture that's going to follow. Back up, sorry. Until you see the next picture, you'll think this is high tech. Again, this is Hubble. This is looking at a nebula. You'll see some stars in it. Next one. But we now have a new telescope. It's called the James Webb. It sent its first images back in July. Now, the James Webb doesn't even really look like a telescope that we would acknowledge or recognize. Not only does it not look like a telescope, but it's not in an Earth orbit. It is at something called the Lagrange point. Next one. So, believe it or not, the sun is a magnet, the Earth is a magnet, and there are places between or around the sun and the Earth where the attraction of one equals the attraction of the other. And so L1 is probably the most obvious one. The pull from sun is equal or balanced by the pull from the Earth, L1. There are another 4. You'd have to be a mathematician to understand the rest of them. There's L2, which is behind the Earth. L3, which is exactly opposite. 4 and 5 precede or follow the Earth in its orbit. James Webb is at L2. It will forever stay there. And the Earth blocks the sun from it. And so it can look in any attitude it wants and takes pictures. It's using IR. It's not optical. It's not something we would see, but this is in the IR range. Next one. And so this is what that nebula looks like from the James Webb. Now you can see details in there. You can see new stars in there. Look at the, I mean, it's just mind-boggling. And the first imagery, it just came down in January. I mean, in July. And so I talked about the technology advances in human spaceflight. The technology advances in the ability to look out. This is an amazing time for kids as they're growing up and they have the curiosity to look out and say, oh my goodness, what am I going to do when I grow up? and it almost becomes obvious. Next one. So we're looking at way out into our universe, and this is this galaxy right here is called Hercules. It's only 1 billion light years away from us, but that comes from the James Webb. You're seeing about 5,000 galaxies right here. Remember, we're the Milky Way? There are between 200 billion and 1 trillion galaxies in our universe. And so if you think you're alone, every one of those galaxies could very well have solar systems, could very well have planets. And we've found planets that look very similar to Earth. And so even though I've never seen anybody out there yet, I know that they will. And maybe these kids will be able to recognize and see them sometime. It's going to be it's going to be an amazing day. Next one. Earth and Mars. Every now and then they come close together, like you see right here. But even when they're close together, using old technology, it still takes us 8 months to get there. From Earth to Mars, 8 months. But you have to leave Mars before Earth and Mars separate. And so you can only stay on Mars less than a month. Then you get back on the vehicle and come home, 8 months. The object of the exercise is not the transit. I don't care about a human surviving for 8 months. What I want to learn about is Mars. What about Mars? And so I want one of these kids to come up with a way to get me there in 2 weeks instead of 8 months. And I think it's possible if you put that out as a challenge. Next one. And then we can start a colony of some sort up there as we anticipate where we're going to go next. See, this journey never has an end. It just gets you to a milestone, and then it gets you challenged to go to the next one. Next one. So who's in space? Well, this is the International Space Station. Generally 7 people are on board conducting science. There's another space station up there, and it's run by China, that generally has 3 people on board. But what are they doing on this thing? I have no idea. So there's obviously a communications problem about the importance and the significance and what they're actually doing between that and me, who's supposed to be voting for it. Well, if I were somebody who had power to vote, why would I vote for something I had no idea what they're doing? And so that's one of our problems, and we have to figure out, how do you take the significance and the importance of a program like this and make it relevant to you so that when it comes time to pick and choose for those things that are important, this is near the top. So what I would propose is that we next have a Holiday Inn Express up there. That's where all of us Joe Bag of Donuts can go up, and we can spend time and begin to understand and associate ourselves with being off the earth. Now this is a rotator like this. And so on the outer rims, you have gravity. And as you move toward the center, no gravity. That's where I want to put my swimming pool. And so I need somebody to figure out how I keep water in a swimming pool in 0 gravity. That's another challenge to these kids. And I think they can do it. I think if you give them challenges like that, they'll figure out that they have to study STEM. I think the opposite is study STEM and then try to figure out why that's important. So this is amazing. But next one, waking up and looking through the windows at your vista down there, and then thinking about, what am I going to have for dinner tonight? Oh my goodness, a space meal. Next one. Well, here we are, we're on Earth, we're looking out. The question is, what are you going to do that's going to be significant? That's going to, kind of raise the bar. And this is the kind of thing that excites me about the future. We've got so many great ideas about the future.